Thank you very much. Welcome to this webinar on enhancing Earth observation data access for sustainable development. My name is Alan Naware, and I am a GS developer with ICPAC. So just to give a brief overview, ICPAC started as a drought monitoring center back in 1986 to help reduce impacts of drought and other natural disasters. So in 2007, the protocol established in the center was signed and the name changed to IGAD Climate Prediction Application Center. ICPAC is a WMO, Regional Climate Center for Eastern Africa. So in terms of the geographic coverage, we cover 11 countries, including the 8 IGAD countries, and then plus Rwanda, Tanzania, and Burundi. In terms of the thematic areas of work, ICPAC work across climate forecasting, disaster risk management, water resources, agriculture, food security, environmental monitoring, plus other areas. And where the GMES and Africa program is anchored is with the ICPAC's objective to enhance use of Earth observation and geospatial technologies for monitoring natural resources and food security in the Eastern Africa region. Talking of Earth observation, looking at one of the largest programs for Earth observation, that is the Copernicus program. This is under the European Union. So Copernicus is one of the largest EO data provider in the world, and data is coming from different satellite missions, from scientific missions. There are other missions for environmental monitoring and also other missions for meteorology, which are under the EUMETSAT agency. So all these satellite missions are providing data. Right now, the data archive is at 250 petabytes of data, and the daily growth of the data is around 220 terabytes. Earth observation data is basically considered as big data in terms of the data, the volume, the velocity, and veracity. So basically, and the challenge that we are trying to address is how do you transform all these large amounts of data into useful, accessible information in order to support evidence-based decision making. So the data in its raw form, it's not that useful. So we have to translate it into meaning and provide context so that it can be applied in different applications. So basically we have to basically make sure that we can translate this data, the raw data, into actionable insights based on evidence. In terms of the data infrastructure, we have under the GMES and Africa program, we have around 14 satellite data receiving stations, which are distributed across the region, and these stations assist in acquiring data without the need for internet. So basically, all these stations are being hosted by different government agencies across the region. So, and basically through these stations, the government agencies are able to access data products coming from the Copernicus program. So ICPAC has been supporting the maintenance of these stations and also also provides data gaps filling and capacity building. So these are just the stations in the region, but there are more satellite data receiving stations which are in other parts of Africa. So through the e-station, which that's hosted at ICPAC, there are different data products which are received. For example, vegetation product, atmospheric monitoring product, rainfall monitoring products, fire products, ocean data to do with marine services, temperature monitoring, and forecast products. So all these data are acquired through the e-station software, and they are also processed. So we have the input data, and also there are some derived products which can be visualized and analyzed through the e-station software. So in terms of right now, we are transitioning to eStation version 3. So previously under the MESA, the AMEST, MESA programs, so we have had different, the eStation version. So the latest eStation version is the version 3, whereby which and some improvements that have been incorporated into the version 3 is automatic data acquisition. So the eStation does not necessarily rely on the satellite antenna, so the data can be acquired from internet sources. So once the data has been acquired, can be processed and be visualized and analyzed through the eStation software. So apart the other improvements on the eStation, the new version of the eStation is automatic processing chains, which have been integrated. We have the Jupyter notebook application, and also Impact Toolbox, which assists in analyzing satellite data. So all the data that's received through the eStation is basically disseminated through the online data hub, which ICPAC runs. So we have the online data hub, which is can be accessed through the URL gmes.icpac.net, and from here, anyone can be able to request for data. You can be able to select which data products that you want to download, and you're able to download these data products. So just basically, you can be able to select the specific data product that you want. If it has to do with vegetation products, if it has, for example, the vegetation indices, NDVI, dry matter productivity, all these data products are available through the online data hub, and one is able to select the specific derived products and be able to select the time period, the file format, and also specify the region of interest. So if I'm only interested in a specific administrative unit in a country, for example, I like to get data for a district in Uganda, I should be able to select that. I should be able to select my region of interest, and I will be able to download that data set. So this is the screenshot of how the application looks like, but you are able to access all the different data products. So what is the data hub trying to address? So we're trying to address the issue of discoverability. How do you access the data that's coming through the eStation? So you can user can be able to discover the different data sets. The online data hub is also quite easy to use and is customized to user needs in terms of the location, in terms of the time that the time period that you want the data for, and also the format. So there are different formats for different users. So for analysts, you have the GOT format that you can download. For someone who just wants to get like a snapshot of the data, so you have like the PNG format that you can specify, and also you can also specify CSV if you want to do further analysis. So right now we have automated the online data hub. So right now it's quite easy. The time period that you will request for the data and get the data, the time has been reduced. So within a few hours, you should be able to access the data. Previously, you had to wait for the data to be processed by a human operator. So we're just trying to increase the audience for the data, and also to be able to make sure that the data sets are provided to different customer needs. So apart from the online data hub, ICPAC also provides a geoportal. A geoportal, this is quite, the ICPAC geoportal is quite similar to other geoportals which are online. So you can access different, both the raster datasets, vector datasets, they are all accessible from the ICPAC geoportal. So I will provide the URL at the end of my presentation. So apart from the geoportal, we also have different tools and applications. So these tools and applications are tailor-made towards different users, towards different thematic needs. So we have an application for agricultural monitoring, for monitoring agriculture production across the region. That's the East Africa Agriculture Watch. We have the Hazards Watch. So this is for hazard monitoring, for disaster risk management. We also have the East Africa Drought Watch, which is targeted for drought monitoring in the Greater Horn of Africa. We also have the climatic analysis dashboard, which can still also access snapshots of data from the East Station. So all these tools and applications are free to use, and they all can be accessible. Their links can still be accessible from the ICPAC website. So coming into cloud platforms, in the last 5 years, we have had an emergence of different Earth observation cloud platforms, and these cloud platforms they provide a better way of translating all these huge storages of Earth observation data. So we're able to translate all these data sets into applications. So right now, instead of taking the data to the application, we're now bringing the application to the data. So I'm going to just mention a few examples of these Earth observation data cloud platforms, which assist in improving access to Earth observation data. So one example is the Copernicus data space ecosystem. So this is being run by under the Copernicus program by the European Space Agency, and we can, through the Copernicus data space ecosystem, you should be able to access all the data sets, all the data sets which are being collected by the European Space Agency. You should also be able to access them through an API, be able to visualize, and there are also some analysis tools which have been integrated in the platform. This platform is free to use, so all you need to do is to register, and you can log in and access both search for data, visualize your data, and you can also analyze your data, for example, in Jupyter Notebooks. The other platform that I can also talk about is the Dunia platform. This is a new platform which was launched recently, and Dunia is an all-in-one, easy-to-use processing and Earth observation cloud platform, which is targeted to African users. So African users have specific needs when it comes to Earth observation data sets. So the platform has developed with the needs of African users, and it's quite possible to access data, and to analyze data and download data in low bandwidth situation where we all experience. The other platform that I can also mention that I think most of us have also had some experience with is the Digital Earth Africa platform. This is also a free cloud-based computational platform, which also enables different users to track changes across the continent. So we have the DEA map, the sandbox, and also the notebook repository. So looking ahead, I think we need to put more efforts into improving Earth observation processing and storage capabilities to be able to scale and leverage new technologies. So also to ensure easy access to Earth observation products and services, we need to have tailor-made tools and applications. So there are also some standards which basically improve access to Earth observation data and products. So these are, for example, open data, open science, and open source standards. For example, the analysis ready data, cloud optimized GeoTIFF. We have the Open Data Cube. The Open Data Cube is supposed to assist in managing of Earth observation data. So, and also the Jupyter, not forgetting the Jupyter Hub for analysis of Earth observation data. So I think that one, I think my time for the presentation is up. So I just leave you with the links to some of the portals and platforms and applications at ICPAC. Thank you very much. We'll handle questions at the end. Thank you.
Thank you so much, Mr. Ware. I hope now I'm able to be heard by everyone. Is that so?
Yes, we can hear you.
Thank you. Maybe, Mr. Oware, we can handle 2 questions that are burning, and then we can have the other, all the other questions in the Q&A. I would encourage participants to interact with the Q&A. Type your questions there. We shall handle them by the end of the presentation. But now we can take maybe 2 questions from Mr. Oware. And all the panelists, the presenters, kindly put on your video when you're presenting, so that we can be able to see you and match the voice with the face. So any 2 burning questions that we can pick from Mr. Oware? And if there is none, we can go to the next presenter, Mr. Maina.
Okay, thank you
Yeah,
very
I
much.
think no questions for Mr. Oware. Yeah, karibu sana, welcome, Peter Maina, thank you. And put on your video so that you can be able to see you. Perfect.
I'm here. Thank you. My background might not be that good. I think there's a lot of light at the background, but I think you bear with me. So my name is Peter Maina, and I'm a remote sensing scientist from Wildlife Research and Training Institute. And I have a presentation on the case studies on how we've been able to apply much of the data, the Earth observation data. So I'm just going to share my screen right now. So let me go to the presentation mode. And I hope now you're able to see my screen. So
yes, Peter, you're good.
So my presentation is on the application of Earth observation data in the field of wildlife conservation and ecosystem management. So as I had just mentioned, I work with the Wildlife Research and Training Institute, which is a research institute mandated to do training and also wildlife and coordinate also wildlife research in the entire country. It was actually established in 2021, and among the functions, which is actually mandated by the law, is undertaking research through the use of geospatial tools, so that at least you can enhance wildlife conservation and management, especially in policy and decision making. And that is where I come in as an expert to translate, to give support to ecologists in their research, and then translate that to information which can be used by managers to give to make decisions. So one of the applications that we've been having is invasive species mapping and control. And you realize that invasive species have been a menace, especially not just in protected areas in Kenya, but also outside protected areas and the entire world. They have been a menace. So we have been mapping these invasive species, starting with the Lake Nakuru National Park, where you see the map on the left, and using the Copernicus data from Sentinel, we were able to map the major invasive species, which were actually maybe Ocimum, Solanum, and Taconanthus. And if you look at the percentage cover, 38% of the protected area, which is 188 kilometers square, is actually under invasive species. Not to mention a few of them, which are not able to be picked based on the spatial resolution. And based on these results, the management of Wildlife Research and Training Institute picked it up to map the invasive species, and within the headquarters based at Naivasha, which is the Central Rift, and have permanent sampling plots where now we are doing habitat management in terms of invasive and monitoring how that is working on. The other thing is on ecological assessment. Every time we have to introduce new wildlife to a new habitat or to an area where they used to exist, we have to do some ecological assessments, habitat stability assessment, where we do vegetation assessment, and we want to establish do we have enough biomass? Do we have enough vegetation? Do we have enough vegetative material for the species to be introduced? And this is done in most of the protected areas where we are either doing species introduction or introduction. The other thing that we normally do, the application is the management planning. Remember, if you don't plan what you are managing, then means that you'll have an issue when it comes to just small adjustments or small changes within the ecosystem. And also remember, the ecosystem is dynamic. So you also have to include to consider the ecology of all the species and also the human aspect. Remember, much of the wildlife in Kenya is outside protected areas. So how do you make sure that there is continuity of wildlife conservation in Kenya without interfering with the existing or upcoming human activities? So what you need to do is do a management plan. So all the protected areas in Kenya have a management plan, and they are all based on the protected area planning framework. And one of the key attributes of this protected area planning framework is stakeholder involvement. So you map the resources. We call them the key resource values, exceptional resource values. You map them. You involve the communities. And then using satellite data, you are able to pick what is actually on the ground, including settlement, vegetation, and all that. And then you are able now to come up with some zonation schemes, whether it is for the ecology, and with that you're able to delineate areas which you need to keep off much of the human activities for the species survival. Again, when you also come to development within protected areas, remember you also have to get revenue from protected areas, and some of it is visitors, and that includes building of visitor facilities, including ecologies and lodges. So you have to make sure that you use satellite data imagery so that you don't have a lot of visitors going to a certain area which is actually ecologically sensitive. So based on that, you are able now to have a balance between wildlife conservation and also ensuring livelihoods for the communities. The other thing is mapping of wildlife corridors and home ranges. So most of the protected areas in Kenya, and I'm sure it's not just in Kenya, they used to be linked from one protected area to the other through corridors. These corridors, based on the changes in land use and land cover, especially land use, they have actually been disconnected. But we still have a few of them who are actually remaining. So we use other observation data so that you can map what is available, what is there that is available and can connect, and not just connect available, but it's also viable. So there are so many factors that you consider so that you can come up with a decision that corridor is actually viable. And then from there, once you realize that it is viable, then from there, you present this to management, and then they can either acquire the corridor through either purchasing, easements, or even coming up with conservancies. The other thing is land use and cover. I think this is a very common application, and you realize that most of activities that are going on around conservation areas, they are actually not compatible with conservation. So we have to make sure that you identify the competing land uses, and then vis-a-vis the compatible, the conservation compatible ones, and then adopt a mechanism to make sure that there is a mix and there's a balance in terms of sustainability. Otherwise, much of the land was under conservation has actually been either subdivided, has been fragmented, because people don't view wildlife as a competitive land use. Someone would like to sell land just because feels that it is not as they might get more income as compared to wildlife conservation. So When you do land use land cover, and the changes that have been existing, then you are able to engage the locals or the landowners and come up with the best mechanism or the best approach. Especially in Kenya, we have the establishment of conservancies, which is the model is really working well. The other thing that we normally do is for every protected area in Kenya, we do ecoclimatic conditions monitoring. This is, we want to see the monthly NDVI, we want to see the monthly rainfall, we want to see the averages, maximum, and even the anomalies in terms of either rainfall or vegetation. And from there, you can even now advise the manager on what do you expect based on the current situation, so that you become proactive rather than reactive. And it is actually working very well. The other thing we normally do is fire monitoring and tracking the spread. Most of the savanna and forested ecosystems are actually prone to forest fires. So what we normally do is we use remote sensing to actually track much of the whatever has been actually the fires from origin and how it is spreading. And based on that, we are even able to deploy the team that is supposed actually to go and distinguish the fire, or even after the fires have actually been put out, you are able to monitor the biomass that has, or the vegetation loss that has actually been affected by the fires. And remember, fires not only affect the vegetation, but they actually destabilize the entire ecosystem balance, since they either kill or drive wildlife away and even destroy the vegetative or grazing or browsing material for wildlife. And I think that is the end of my presentation. I'll maybe take it back to the moderator for the other session. Thank you.
Thank you, Maina. Thank you so much for that presentation. I think we have two questions here that will go to Mr. Oware. I would encourage people to write their questions in the chat box that we can have one or two at this point, as we also wait for the questions in the Q&A that we will take by the end of the session. There's one question here for you, Mr. Oware. Someone is asking, to what extent can we get the continuous data? That is the first question. And then there is a question on how the data on Hub, is it available on time capturing, and how long does the data on Hub take to be fed to the system for users to access them? So, Mr. Oware, those two questions,
Okay.
maybe I can repeat. There's a question on what extent can we get the continuous data? That is the first question. And the second question is that, is the data on Hub available on time capturing? And how long does the data on the Hub take to be fed to the system for users to access them? And what is the working capacity for that data?
Okay. Okay. Thank you for those questions. In terms of how soon you can access the data. So basically, as soon as the data is received through the infrastructure that we have, the data is available, is made available through the online data hub. So basically, that is the latest data that you can get. So let's say in case you want NDVI or you want the CADOL NDVI. So if you go to the platform, you should be able to get the NDVI for the last 10 days. So that is how current our platform is regarding data products and access. So the other question, I did get it properly. So in terms of, is it about yes, the data is the data is time series data. So if for example, if the data was available being captured by the satellite has been captured by the satellite for the last 20 years, then you'll get that data. The data archive is quite complete. data archive that you can access through the online data hub is quite complete. So you're going to get the full data archive, and there'll be no gaps in between. Thank you.
Thank you, Alan. Thank you, Alan. There's a question from one Abebe Kebede. He's asking how to get high resolution climate data, and where are the stations where the stations do not exist. He's able to access any high resolution climate data where the stations do not exist. This is directed to you, Mr. Oware.
Okay. I think I'll give one stab at for that question. Then I think we'll have a bigger discussion at the Q&A at the Q&A session. So for the climate data, right now through the platform you can access CHAPS data. So that's the data that's available in the platform. So and then you can also access. So the data that we are providing, this is data that's coming through the e-station, but you also have data that's coming through the PUMA stations. So these are now the data for meteorological and climatic data. So this data is also available, and through the PUMA stations, you can also access data for data coming from the global meteorological and climate models.
Thank you, Alan. Thank you, Alan, for that. I would encourage participants to continue dropping their Q&As so that we can have that discussion after this. And let us also interact, network, and have a network in the chat area so that we can know who is in the house and what capacity they have, so that we can be able to enable ourselves in these EO data sets and monitoring and access of the same data sets. I would want now to welcome Madam Tinebe Johannes. I hope I got your name right.
That's
Tinebe
right.
Johannes.
Yes, that's right. Can you hear me?
Yes, we can hear you. Yes, clear.
Much Eunice.
Welcome.
So,
yes.
Thanks.
And give us the advantage.
So my presentation is. Oh, sorry. I will just make it turn it on for a brief time.
That is fine.
The camera is not so clear. Okay, I'll just turn it on for the time being and be able to make it off because the internet, the bandwidth is so slow. So my name is Tinebe Johannes. Today I'm going to talk to you briefly on application of Earth observation data, mostly on the water resources side and the application in the food security. So I'm a research associate within the World Resources Institute, and I'm also a vice president for Women in GMS in Africa. So I'll just turn it off for the video. I'm sorry, Eunice, but for the Q&A, I will try to make it off.
That is fine. Now that is fine. It's okay.
All right. Thanks so much. So as two of my colleagues before me have already noted without the application of Earth observation data is immense in terms of the wildlife, in terms of application on climate, but specifically what I'm going to talk about is water resource management and food security. These are just a simple list of the water resource side, for example, monitoring of crop health and yield, drought and flood monitoring, water availability and distribution, climate impact assessment, land cover, as most of you know, early warning system, soil moisture monitoring. So among these, I will mostly focus on the two of them, especially for the early warning system and monitoring of crop health and yield. So when we talk about monitoring of crop health and yield, when we say Earth observation data application on this one, and especially for food security, what most of the decision makers and policy or those who's working on the planning side will have a lot of gaps in terms of data. So when we use Earth observation data, especially when Alan told us there is monthly, there is hourly data, there is even some sub-hourly data, like 15 minutes or so. So when we monitor that in time, those who are making an intervention will be able to get most information on time and will be able to have a very good understanding and be able to have good decision making in terms of timely as well as spatially. The good part of the revision data is having it spatially distributed. It's not going to be point meteorological data, and it's not also only based on a specific time, but for almost all the entire EO data now is as a big data, presenting the data as a time frequency of specific gaps intervals, like 15 minutes hourly or aggregating hourly into a day, and then be able to get that in immensely as well as annual or seasonal data. So this would be really a good application in terms of good decision making. And then, as you also heard, the UND an early warning, almost all the countries in the world to have an early warning system in food security and water resources by 2027. So almost all the nations are working to have a good early warning system, not only relying on in situ or meteorological data, but also using Earth observation data. So this would really enhance most of the stakeholders who are working on water resources as well as food security, and be able to have a very good decision support modeling system, as well as an early warning system to be able to intervene, especially for vulnerable communities and people or nations. Next slide, please. Can you go on?
Are you done?
Sorry, it's taking time to load. I think it's the internet, but
It's the internet, yes.
Oh, sorry.
Oh, are you back? Yes. We got you back now.
Okay. Yeah, if you go to the second slide. I can be able to share it from my side as well.
I think that would be better.
Okay.
Did we lose you? Did we lose you? I think we
Sorry?
lost her. Are you on? Did we lose you?
I can hear you very well. Can you hear me? No?
Yes. Now you're back. But you're having some background noise.
Oh, I'm sorry.
Are you able to put on the slides? I think we lost the slides.
Now my slides?
No, they're coming. Yes.
Perfect. Sorry for taking time with this.
It is okay. It is okay. Now you're back.
Okay. So I've been talking in the first slide, most of the application, and I actually wanted to stress out on but I touched up on few on the food security side, but on the water availability side, I want to highlight some work that we have done for Ethiopia. In 2019 until 2023, there was a project called Baseline Water Risk Assessment for the case of Ethiopia. And then in that project, what we have done were entirely using Earth observation data to be able to work on modeling by the water demand as well as the water supply side. On the demand side, we have taken off irrigation, industry, domestic, and livestock, and be able to see the use of the water demand and to analyze based on the supply. So the supply is modeling from GeoGAS, and was mostly we have taken the data mostly from the ICPAC. For example, from ICPAC, Alan was mentioning about the precipitation data. There is already 5 or more precipitation data sets that are available for example, for trips, it's almost 40 plus years from 1981 until this month, or even there are some 10 daily data, and there are that data is be able to analyze the trend of the precipitation, and then be able to see the comparison of the water supply and the water demand. So based on that, that modeling approach has been given to the Ministry of Planning and Development, and that ministry, during that time, they were working on the 10-year development plan of Ethiopia, and then the water aspect was really lacking. And then because for having spatially distributed data like water was really a very new approach in terms of putting that into spatial distributed, as well as putting that into the planning section. So for that, we were able to contribute for the planning, or for the 10-year development planning, and that was a very good buy-in and accepted with most of the ministries that into the planning process, and that document is actually available online. So this kind of data that can be found in using the Earth observation can have a lot of influence in terms of policy as well as planning, and having that into the country developmental reports. So, but we all know when there is some advantage, there is always some disadvantage. So we have to talk about the challenges in the adoption of Earth observation data, especially focusing on the water resource management and the food security. So there's always infrastructure limitation. That's when the e-station that Alan was talking about is completely working in parallel to online. There is offline assessment, and we don't need internet to get the data, the hourly data, the even less than hourly data. And then integration with the ground data. Most of the people that are working especially for decision have a lot of challenges when it comes to using only Earth observation data. So they always prefer, of course, the primary data, but integration with ground data, especially for validation, is very important. There's some challenges in terms of getting the ground data, and even be able to integrate that into the Earth observation data is always a challenge. For example, for trips, the S part in the end is from the station, and for the rainfall data is not entirely using remote sensing data, but it's validated and integrated with station data for Ethiopia. More than 300 plus station data is integrated into that rainfall data set. That's actually a very good approach in making it validated data as well as making it accurate. We hope that will come also in the in other data, especially for evapotranspiration, humidity, air pressure, and the like. And then always a problem of data interpretation and challenges. It comes with a lot of formatting, for example, GeoTIFF, NetCDF, and with ChatGPT integration into this kind of data, it makes it always a challenge. But that's the worldwide. There is somehow integration, making it a common format, and then be able to disseminate that for the users is undergoing. It's still going slowly, but it will come. And then the regulatory and data sharing barriers for validation purpose, I touched upon to the ground data. Usually some ministries or some ground data working, especially if it's, for example, for Ethiopia, almost all the basins are transboundary, and it makes it very challenging to be working on the water resource side and to be able to get accurately and be able to validate the remote sensing data. Limited technical expertise, challenges working on the early warning system interpretation, and to use that for intervention is also a big challenge. And the last one, sustainability in long-term adoption. If there was some challenge, people doesn't have a lot of patience, especially if in terms of big data and changing that into an information, and then that information changed into policy and planning. It will take a lot of time. It's not so easy. And then to make it even sustainable, for example, integration into an institution and integration into the university will take a lot of time, but that's also a challenge when it comes to application in the observation sector. This is my final slide. How does the future look like for the observation, particularly in Eastern Africa region in Africa? Peter was taking this a lot, especially when it comes to Africa. We need a lot of integration in terms of regional application, like ICPAC is currently doing. Like for climate is not boundary specific, there is always outside boundaries, and we need to act by the multi-level approach. So increased accessibility to satellite data is one of the future that has to be taken into consideration. And then advancing in the big data and AI integration, like the Global Earth Engine is online. And most people are working on it. That kind of system for Africa, especially for African Eastern African region like Dunia, that French president has been showing us, is really a good approach. Expansion of regional EO initiatives like the ICPAC and RCMRD, especially within the GMS and Africa projects. There's regional implementation centers regionally, and that's really encouraging for the application on observation data. And improved drought and disaster early warning system. The early warning system to be taken into consideration, there is always a need to make it accurate. So we make it accurate when it comes to application in terms of ground-based data, and then when we improve the data and be able to have that in modeling and be able to get that online, be able to get accessible throughout the time. And then when it comes to climate change, we always talk about the carbon sequestration, anything like that, but we need to really enhance it models, less from the global climate models. Regionally, there is coordinates, of course, but regional climate models, but we need a high resolution, spatially as well as temporally, in order to get a very good output out of that. And the increased collaboration between government and the international organization is also one of the main thing to be considered in the future, like multi-level governance, both vertically as well as horizontally. And then growth in local capacity and expertise. EO initiatives, associations is always encouraging. And then with smart technology that's available in the body. This application for Africa is also immense. And finally, last final but not least, the private sector engagement that currently, for example, for ICPAC, I know there are a lot of initiatives that encourage private sectors. If private sectors gets into EO, this will make it a lot of influence in terms of application of observation and be able to make it sustainable in terms of the future for Africa. This is my last slide, but I would be really happy to chime into the Q&A session and to discuss more on these topics. Thank you very much. Back to you, Eunice.
Thank you, Madam Tinebet. Thank you for that good presentation. I think we are getting learned as we go on. This now will be purely Q&A time. But before then, I would want to say that Mr. Oware has dropped the links in the chat, so you can check them out. We also have the presentation the presentations have been dropped by Paola in the chat. The recordings will be shared, and you can access them through the ICPAC YouTube channel. Yes. Now, let us go direct to the question. And I would also want to request that if you want to ask your question verbally, you can raise your hand so that we can give you a chance to ask that question verbally. But because I see no hand that is raised, let us go to some questions that are in the chat box. And one question goes to Mr. Oware. There is a question on how remote sensing tools that can be used for fire monitoring. If your tools are able to do fire monitoring, which remote sensing tools can you use for fire monitoring? There is also a question to Mr. Oware on Mr. Haytham from Sudan. Met is asking that I am here in mission concerning drought early warning program. So I'm interested in satellite data. And his question is about MTG satellites data manipulation by using specific Python library for image analysis. So he's asking, is there any panel working in this issue? That is one question for you. Two questions now. I think we give Mr. Oware a chance to answer as we wait for anyone who will raise their hand, and then we can go to Mr. Maina. I can see a question for you, and then we can go to Tinebeb. So Oware, Alan, kindly come over and address the two questions. Thank you.
Okay. Thank you for those questions. For fire monitoring, yes, we do have some tools for doing fire monitoring. So for example, the satellites which provide sensors for fire monitoring include MODIS satellite, the SNPP satellite, and also even Sentinel-2. Through the different bands, one can also do fire monitoring, and all these tools are accessible through the EO cloud platforms that I mentioned, and the data can be accessible from the online data hub. You can also access these data products through the East Africa Forest Watch, which I also mentioned. So you can get both the active fire and also burnt area through these platforms. For the MTG data, right now I think we are still in transition from Meteosat second generation to third generation. So the MTG data that we have right now, it's more of like sample products. We are still not getting the operational data products from MTG through the EUMETSAT. So this will be available, I think, in the next coming months. Yeah. So I think those are the responses. But I think I invite my colleague Peter in case he has anything to add on fire monitoring, especially for forest fires.
So thanks, Alan, for that. I think you've answered it conclusively. In monitoring of fires, we actually use MODIS and also the band combination in Sentinel-2. And that is how we are able to track, even tracking the spread of the fire. So I think what you've answered is correct. Thank you.
Maina, before we get, now that you're on the floor, there is a question for you. Okello is asking, Simon Peter is asking, apart from map presentations for the various applications like mapping land and land cover changes, can you help explain to us the possibility of a geographical presentation like histogram with some numbers again? Because he thinks it is an easy way to grasp than maybe seeing it on a map. He's asking if you have any other manipulations for your data. Peter.
Thanks, Eunice, for that. The question that has been asked is a good one. So if every map that I've presented has got statistics, and I can give those statistics maybe later, but all the maps that you have shown there, they have statistics. All land use, land cover maps, they have statistics in terms of the classifications of the various invasive species. All of them have statistics, and those statistics are what now you combine and do some models, and you present these as very synthesized information to managers. or provide the maps plus the statistics. The background, most of these managers don't have the geospatial background. So yes, we have all this, and I can share the statistics. It's only that I didn't want to make my presentation that busy with the statistics, but the statistics are there. Thank you.
Thank you, Peter. Thank you, Peter. I can see we have one hand that is raised by Maurice Manika. I will let Maurice come in so that he can ask his question verbally. So, Karibu Maurice.
Maurice, you can unmute and speak.
Maybe Paula, before we get Maurice back, I think maybe he's trying to reach us. We have a question for Madam Tinabeb. We have one question that has been asked by Abeb Kabede. What is the main mechanism of integration of your data set, Tinabeb? And there's another question by Eliud Baraka. He's asking, how can you convert the Earth observation usability challenge to scalable opportunities in your area of application? So, Madam, the floor is yours.
Thank you, Eunice. I'd like to say thank you very much for Abeba for this very interesting question, main mechanism of integration. When it comes to Earth observation data, we're always informed of models and platforms. For example, for water resource sector, there is a platform called Integrated Water Resource Management. In the integrated approach, a lot of stakeholders working in the water sector will be in that platform, and we have actually very regular meetings in terms of updates in the data access, data sharing policy, and especially for the case of Ethiopia, there is a Meteorological Institute, Ethiopia Meteorological Institute, Disaster Risk Management Office, even there from the NGO, FAO, World Meteorological Organization, represented in Addis, and a lot of sectors that are working in the water will be, some have a platform. This kind of mechanism will make it very easy to have an integration. And this is not also working in the water sector, almost entirely in other sector actually. And the regional offices like ICPAC plays a very significant role having this kind of forecasts, taking into consideration of a lot of institutions working in the regionally from these 14 plus countries, and then be able to integrate that in one spot to get in ICPAC website and to have a monitoring system. So this kind of mechanism will make it more easier, especially now, also in the future, if there is an integrated body. In my view, integration will come when there is a central pivotal institution. So the main mechanism would be that one, as to my understanding. Can you please remind me the second question? Eunice, can you hear me?
The second question was on how you can convert the Earth observation usability challenges to scalable opportunities. Is it that one?
Oh, yes, that's true. Oh, the challenges to convert into an opportunity. Yes, I mean, in almost, for example, for almost in Africa, an internet was an issue. So taking that into consideration, into Earth observation data, be able to invent e-station working offline is one of an opportunity for almost 48 plus countries in Africa to be able to get that kind of data offline and to convert that into a model or an early warning system, and be able to have a decision which would be using the observation data. This is one for an internet challenge. And there also, for example, in the climate sector, the regional implementation centers like Cortex work on changing almost all institutions used to have a lot of formats, and then that Cortex play a significant role changing that format into one format. And NetCDF was used to be one that was working on the climate sector. So this is changing that kind of challenge into an opportunity. So this is also my observation in the observation sector. And I'm happy to elaborate further if would be interested. Thank you so much. Ian, is back to you.
Thank you, Tinebe. Thank you. I would want to maybe invite Mr. Moritz if he's able to join verbally for his question. If not, I would also want to put across what Eliud Baraka has said. He's Job Kellygen. He's appreciating the work that is presented, Madam, and he's suggesting as a value. He's suggesting that on ways you can add value to your data, you can look into FAO open source data and focus on focuses on water productivity, also in agriculture ecosystem. And thank you. Also, we have Khalid Kirema, who is appreciating the IGAD work, and he's applauding us for that work. I'm trying to get ready for Mr. Moritz if he's not able to join us. And if there is no other question that we can be able to handle, we would want to bring this webinar to an end. I don't know if Moritz is there. I don't want to close the session before he asks his question, but I've been trying to do a clarion call and I'm not able to get him. So I don't know.
Eunice.
Yes.
Yes, someone had, I think in the chat, I saw someone mentioning about how do you access the climate data, like, for example, the combined climate data, for example, SPI. So
yes,
within
Alan, please go ahead.
Yes. Within the East Africa Drought Watch, which is the tailor-made application for drought monitoring, we have, for example, the SPI products, both the 1 month, the 3 months, they're available from the platform. They're available for visualization. So you can go ahead and visit the East Africa Drought Watch. Also, the East Africa Hazard Watch also has the SPI products available for visualization. For download, we are in the process of incorporating these data sets in the online data hub. So you should also be able to access them in the coming months. Thank you.
Thank you, Alan. I hope I've not missed any other question. Maybe you can help me run your eyes into the chat box and the Q&A. I hope I've not missed any questions. In the meantime, I would want to appreciate and give thanks to our discussants, Mr. Alan Oware, Mr. Peter Maina, and Madam Tinebe. Thank you so much for making this discussion lively and giving us wisdom on matters EO data sets. I also want to acknowledge ICPAC, GMS Africa, and African Union, led by Dr. Bashir. Dr. Bashir, who is in attendance, thank you so much. Feel appreciated. I would also want to give thanks to Eugene. Mr. Eugene, thank you so much. I also want to give thanks to Paula. She's around. Thank you, Paula. And I see that we have a hand from Michael Edema. Let us not close you off, Michael. So let us hear from you, Michael. Please go ahead. I'll
yes.
Later.
Okay. Good evening. I'm Edema Michael from Uganda, and I'm a student from Makerere University. So this is a very resourceful engagement, and I would like to still ask this question. I don't know if it was answered, I'm sorry, but then I would like to know how best can I continue with such educative pool, or where can I continue learning from you people? So that is my only question I'm posing, where I can continue following you people, because it is so educative. Thank you so much.
Alan?
Oh yeah. Okay, I've put in the chat. I had put in some links basically for the different websites, web applications, and portals where you can basically visit and be able to interact with the different applications. So we also have different trainings which we normally hold. So you can be checking on the ICPAC website and also the social media platforms to basically for any news on upcoming trainings for basically to do with Earth observation, Earth observation data and products. So apart from that, there are also other online platforms where you can access tutorials. For example, if you go to the Digital Earth Africa, I think there's a very comprehensive training resources for you to be able to access and interact, go through the exercises. So also, I think even the other platform that I mentioned, the EO Cloud platforms, they also have different tutorials and example notebooks that you can run through and do your analysis. Thank you.
Thank you, Alan. Thank you for that. Thank you also, Michael, for your question. And right now, there's a question coming in here as we wait for ending the webinar for Madam Tinebeb. There's a question by Okelo, and he's asking the integration of AI into your EO dataset. Is it possible, especially when you focus on machine learning, for instance, Earth spatial? Madam Tinebeb, are you with us?
Yes, that is I'm very passionate in this kind of thing, integration of AI into the Earth observation. Of course, now that for example, from the WRI side, there is a Global Forest Watch, and currently a new version integrates chats GFW, which is a Global Forest W. In that chat, like ChatGPT, you ask the Global Forest Watch, what is a specific tree loss, for example, for Uganda, and then it will automatically gives you in the chat be able to reply within a fraction of a minute. And these kind of things are really, for example, for Digital Earth Africa, for South Africa, that is already customized for ground weather data. And that ground weather data, for example, for Zimbabwe or South Africa, you would ask how much potential in this specific region does it have? And please draw a kind of graph, so automatically you'd be able to get that. AI integration is a lot. Actually, the AI integration, I think it applies mostly in remote sensing and Earth observation sector than any other sector, I believe. But of course, a lot of initiatives are available when it comes to EO and remote sensing in application of AI.
Thank you, Tinebeb. I think that will be our last question. As I had said, we want to appreciate the program manager, GMS Africa and Africa program at the African Union, our manager, Dr. Bashir. We also want to thank Eugene for making this happen at ICPAC. I want to say that this is not the end of the discussion that we'll be having. We plan to have at least one discussion as such. We'll be planning a webinar every month, and we shall be sending out the invitations. Please, if you see our invitation, adhere to it and let us come together so that we can learn. And thank you so much to our panelists. Thank you so much to our participants. Please also be checking the ICPAC website for any updates. And there is an upcoming training with collaboration with the Makerere University that also will be posted in the website. It's a training in collaboration. There is a training in collaboration with the Makerere University. I would want now to bring this webinar to an end. Thank you so much, everyone, and have a nice evening if wherever you are. It is evening. Have a nice morning, which is morning. Have a nice afternoon then if it is an afternoon where you are, and also have a good night if it is night wherever you are. And thank you so much for coming together so that we can learn matters hiyo. Asanteni sana. That is what we say in Kenya. In Swahili, asanteni sana.